Degree and radian measure. Follow along with this activity by finding yourself a compass, protractor, and some kind of straight edge. If you don't have those things, you can freehand it, but it might look a little bit better if you have the appropriate tools. The first thing I want to do is take my piece of paper and draw in an X and Y axes about in the middle. We'll just take our straight edge and draw an X axis and a Y axis. Now I'll just well, actually, let me do this. I want it to look pretty nice, and we do have that protractor. So I'll mark it off to make sure that that y-axis is perpendicular. I'll do this with the protractor instead of the Euclidean tools where I could construct this perpendicular line. There we go. Now I have a y-axis and an x-axis. Let's grab our compass and we're going to mark off a unit. How big do you want it? Well, that's up to you. I noticed my compass was left at this setting and that looks just fine. So I'm going to mark it off to indicate here's 1 unit on the y-axis, 1 unit over here. There we go. So I've marked it off. This point here on the x-axis is 1 unit. This value right here is 1 unit in the negative direction, or -1. On the y-axis, I've made a mark to show that this is 1 unit in the positive y direction, -1 unit in the y direction. And what I'm going to do next is I'm going to create a circle. I'm going to create a circle that intercepts these points, and I could have struck that through right away, and I will do that, but let me just mark off a couple other points here. There's 2. This one here looks like it'll fit on there pretty good. There's 2. I'm just going to mark the x-axis because sometimes I see this left off. In fact, most often I see this left off in the discussion of radian measure and degree measure. Now I only needed to mark the x-axis because what I'm going to do is I'm going to use that x-axis in just a moment. It's just our real number line. Let's draw that circle. There we go. As we draw that circle, it's a little bit light on mine. I'm going to darken it up a bit. There, I darkened it up a little bit. I did notice that these got a little bit hard to read. So why don't we write the ordered pairs next to each one of these points right here? That might be helpful. 1, 0. I'll use red for this one. Actually, I'll just write it in 0, 1. I probably should have color coordinated the x and y coordinates, but -1, 0. I suppose on your picture you could do that. 0, -1. So there I can clearly tell where those values are on that circle. Now the circle, because the real number line here was 1 unit here, we'll call this a unit circle. Unit circle. Radius is equal to 1. Just how we constructed it. What I'm going to do next, I want to bring in the idea of a radian first. We're all pretty comfortable with degree measurement. So I brought with me my magnets. These are pretty powerful magnets, so they like to stay together. And I'm laying it out. I have silver magnets and they're kind of pink or maroon. And the silver magnets show up and they correspond to 1 unit on the real number line. You can see this center one right here is at 0, positive 1, negative 1, negative 2. Might even have a little more room over here. Oh yeah, I've got another one. Well, let's mark this one 3. I told you they were powerful. And if there were more, which there would be because it goes on forever, I could just keep putting on magnets, like so. In this exercise, when we talk about radian measurement, first let's take this real number line. And you'll watch this magnet right here. That's 0. And I'm going to lay it on the circle that we just drew. Now, I'll be careful to pick the real number line up and rotate it so 0 corresponds to this point right here. And what I'll do is I'll wrap this real number line around positive direction this way, negative direction this way. So again, just watch that rotate around. Take my real number line. I'm going to wrap it around my circle. Now the magnets, once they get a little bit too close together, they'll snap together, so I'm just going to leave them apart just a little bit as I map out what's occurred where. So you can see here is 0. Here's 0 right here. And then right up here, there's 1 unit right here. I'm just going to mark it off. And this length right here, this arc length, that arc length is actually equal to the radius. So this arc length right here is the radius. It's just kind of neat, and I have it marked off here. The angle measurement that we'll find at this marking will be known as 1 radian. 1 radian will have this radius length mapped out as our arc length. So where would 2 be? Well, over here somewhere. Here would be 2 radian. Well, how about 3? Remember that 3 that we had over here where that got wrapped around and it's almost touching down here. These magnets are so strong. That's about right here. I'll just mark it off and I'll call that 3 radian. Oh, they did snap together. I'm going to pop them apart again so we can see it. So right down here we have 3 radian. Now, if I go in this other direction, we could call this -1 radian, and so forth. -1 radian. -2 radian is going to be over here. Just mark that off. You'll see -2 radian. And then we could keep going around. And in fact, because our real number line goes on in both directions forever, we can keep wrapping this around all we want. The arc length that we found from here to here is equal to the radius, and so we have 1 radian measure. And we have 3 radian measure that almost reached down here but didn't quite. And if we went all the way around, we'd have 6 radian would get us right about here, so we need a little more than 6 radian if I go from here all the way there, and you could count them out. What I'm going to do next is I'm going to take my protractor and bring that in. And what I'll do with this is I'm going to mark off some common angle measurements that we're comfortable looking at. And maybe I'll do this in red to show them. Well, here's our 45 degrees. That one's very common. We use that regularly. 30 degrees, here's another very common one. Now this isn't a negative sign that I'm putting in here, that's just a mark for my protractor. 60 degrees. There we go. Those are common ones. 120. 135 degrees. Which is just 45 degrees added to 90. 150 degrees. And another 30 degrees takes me to 180 degrees, like so. And I could certainly map it out in this other direction, but I think this will work out fine. Well, what we'll know then, when we're looking at the measurements, 1 radian is between 45 and 60 degrees. We might want to know a little closer what it's equal to. Let's mark off on our unit circle the angle measurements that we just found. So I'm going to mark off 30 degrees. You'll notice I can mark it off right over here and here. So I have 30 degrees rotated from the x-axis in the positive direction. While I did that, I have another 30 degrees marked right here. Since this is 180 degrees, another 30 degrees would put me at 210 degrees. 30 degrees. I have those two marked. I'm going to mark off 45 degrees. So I'll just mark the 45. I'll have a mark over here and here. 45 degrees. This mark over here is 45 degrees more than 180 degrees. 45 plus 180 is 225 degrees. Mark off 60 degrees. Here we can see our 1 radian is actually a little closer to 60 degrees than it is to 45 degrees. That little mark in there. Well, what's this one here? If this is 180 degrees and we're going to add 60 degrees to it, we have 240 degrees. I'm going to pause the video as I mark off the rest of them. Alright, that's done. I've got those marked off. I'm going to grab my magnets again. I'm going to grab my magnets, and what I've got is the real number line marked out again. 0, 1, 2, 3, and I kept going with it. So we'll have 4, 5, etc. And I'm going to take it this time, instead of worrying about -1 radian this way, I'm just going to wrap it around in the positive direction so I can make it all the way over here. So I'll take this value here, which is 0, and I'm going to map it to the circle here, and I'll rotate this real number line around. So what we're doing is we're wrapping around the circle so we can see that real number line wrapped as the arc length around this circle. And again, these are powerful magnets, so they snap together. But I can see, and to my pen, I'm going to point with my pencil. So we'll start here at 0. We've mapped our way over here to 1 radian. And I think it's important that we recognize that that's 1 radian right here. In fact, it is so important. Let me bring my highlighter in. 1 radian is right here. 2 radian is right here. Now as we map ourselves around, we found ourselves with 3 radian right here. We didn't quite touch that x-axis. And now we have 4 radian right here, which I did not write down, but maybe I should. 4 radian right in here. Now let's go ahead and we'll let those snap together. There we are. And what I see happening here is, there was 4 radian. Here's 5 radian right here. 5 radian. We see that happening right in here. 6 radian right here. And there's a little bit more for us to get back to the beginning. So it's more than 6 radian to get all the way around the circle. But what we've mapped out now, all the way around the circle, is the arc length. That's actually equal to our circumference.